Our next topic of discussion is electrochemistry. In this topic, we shall talk about redox reactions, electrochemical cells, electrolysis, calculations in electrolysis, and finally the applications of electrolysis. Enjoy the topic. The topic deals with chemical changes caused by electric current. And production of electric current by chemical changes or reactions. These changes are investigated using electrochemical cells. Types of electrochemical cells. There is voltaic cells, and electrolytic cells. Before we look at the reactions in these cells, let's talk about redox reaction, because we're really going to apply the concept of redox reaction throughout the topic. Redox reaction. Redox reactions involve both reduction and oxidation taking place simultaneously. Some of the examples include reaction between zinc and copper 2 sulfate solution. So when zinc powder is added to blue copper 2 sulfate solution, brown deposits are observed and the blue color fades and finally turns colorless. These observations are made because zinc is more reactive than copper, and therefore it reacts with copper 2 sulfate to form zinc sulfate and copper. So this copper solid is the brown deposits. Then the blue color fades because the copper 2 ions responsible for the blue color have been reduced to copper metal. So ionic equation will be ionic equation. We shall have zinc solid plus copper 2 ions giving zinc ion plus copper solid. So this is the process of oxidation, and this is reduction, Therefore, the reaction is called redox reaction. Another case, reaction between iron and copper 2 sulfate. Iron and copper 2 sulfate. Again, iron is more reactive than copper. Therefore, the blue copper 2 sulfate changes to green solution. The green solution is due to formation of iron 2 sulfate. When the iron 2 ions are realized in the reaction, then the solution turns green. So that is iron solid reacting with the copper 2 ions, and that leads to formation of iron 2 ions plus copper solid. So from this to this, that is reduction, and this is what we call oxidation. Another scenario, you can have reaction between halogens and halide ions. Halogens and halides. For example, when chlorine is bubbled into colorless potassium bromide solution, the solution turns orange due to formation of bromine liquid. Chlorine gas is more reactive than bromine, hence it will accept electrons from bromide ions to form chloride ions, and in turn the bromide ions will be oxidized to bromine gas, and in turn that is why we are getting what is called the orange formation of bromine liquid. So we shall have the reaction as follows: chlorine gas plus potassium bromide. This leads to bromine gas and potassium chloride. To balance the equation, we have 2 there, 2. Then ionic equation will be chlorine gas plus bromide ions giving bromine gas plus chloride ion. So from this to this is reduction, then this is oxidation. So it is the chlorine gas that is oxidizing agent, the reduced species in the redox reaction, and it is the bromide ions that become reducing agent because it is the oxidized species.